In today's video, we are going to cover section 2.5, addition and subtraction properties. After studying this section, you'll be able to apply the addition properties of segments and angles and apply the subtraction properties of segments and angles. So looking at addition properties, this diagram will give us our first addition property. So notice we have segment AB is 7 centimeters, segment BC is 3 centimeters, and segment CD is 7 centimeters as well. So I know AB is congruent to CD. What can I say about AC and BD? Well, if I were to add BC to AC, that gives me a length of 10 centimeters. And if I were to add BC to CD, that gives me another length of 10 centimeters. So I can also say that AC is congruent to BD, which gives me my first addition property, which is if a segment is added to two congruent segments, then the sums are congruent, which we will call the addition property. Now for angles, this works the same way. So if I have angle EFJ is 50 degrees and angle HFG is 50 degrees, if I add angle JFH to each angle, let's call JFH 20 degrees, that gives me an entire angle of EFH of 70 degrees, and again, an entire angle of JFG of 70 degrees. So these two angles would also be congruent, which gives me my second addition property theorem. If an angle is added to two congruent angles, then the sums are congruent. Again, we can call this the addition property. Likewise, in these figures, I have identical tick marks that indicate congruent parts. So again, if I have KR is congruent to SO, if I were to add RM and PS, which those two are congruent as well, that would give me the whole segment PO would be congruent to the whole segment KM. And this also works the same for angles, which leads me to these two theorems. If congruent segments are added to congruent segments, the sums are congruent. And if congruent angles are added to congruent angles, the sums are congruent as well. Now subtraction works the same way as addition because they're equivalent, they're just the opposite. So if we have 4 addition properties, we have 4 subtraction properties. The only thing that's going to change from the addition properties to the subtraction properties is I'm going to change the word addition to subtracted and the word sum to difference. So my 4 theorems, which will be condensed into 2, is if a segment or angle is subtracted from congruent segments or angles, the differences are congruent, and that's subtraction property. Theorem 13, if congruent segments or angles are subtracted from congruent segments or angles, the differences are congruent. Again, this is my subtraction property. So I have 4 addition properties as well as 4 subtraction properties. Now when I want to use the addition and subtraction properties in proofs, if I use the addition property, my segment or angle will be bigger than my original given segment or angle. And if I want to use subtraction property, my segment or angle will be smaller than the given segment or angle. So let's look at a few proofs. So problem 1, I'm given AB is congruent to FE, BC is congruent to ED. I want to show that AC is congruent to FD. So notice AC is my largest segment and FD is my largest segment. So I'm given smaller segments and I want to prove larger segments, so I'm going to use addition. I'm also given 2 congruent segments, so I'm probably going to use the theorem if congruent segments are added to congruent segments, the sums are congruent. So I'm going to start off my proof with my 2 givens. So segment AB is congruent to segment FE and segment BC is congruent to segment ED. Now when I add these 2 segments together, it will give me line segment AC is congruent to line segment FD by the reason of addition property, but if congruent segments are added to congruent segments, then the sums are congruent. Looking at problem 2, I'm given line segment GJ is congruent to line segment HK. I want to conclude that line segment GH is congruent to line segment JK. So notice GJ is my bigger segment and HK is also my bigger segment. HJ is in the middle Therefore, if I want to show that GH is congruent to JK, I'm going to subtract HJ from both of those segments. So I'm going to use the subtraction property. So my first statement would be my given. Line segment GJ is congruent to line segment HK. Then I can conclude that line segment GH is congruent to line segment JK, because if I subtract a segment from congruent segments, then the differences are congruent. Notice how I have the segment listed. I don't need to list the segment that I subtract. If you want to, you can. It is not necessary. Looking at problem 3, I'm given angle NOP is congruent to angle NPO. Angle ROP is congruent to angle RPO. I want to prove angle NOR is congruent to angle NPR. So notice angle NOP is my larger angle, likewise with my angle NPO. So I'm going to use subtraction because I'm going from a larger angle to a smaller angle. Notice that I have congruent segments subtracted from congruent segments, so I'm going to use that theorem. So I'm going to list my two givens as my first statements. Angle NOP is congruent to angle NPO. Angle ROP is congruent to angle RPO. Then I can list my prove, which is angle NOR is congruent to angle NPR, because if congruent angles are subtracted from congruent angles, then their differences are congruent. Looking at problem 4, I'm given line segment AB is congruent to line segment CD. What can I conclude? Well, notice I have line segment AB here with my tick mark and line segment CD here with my other tick mark. Notice I have BC in the middle, so I can conclude that line segment AC would be congruent to line segment BD, because if I add BC to both of these segments, then I will have the bigger segment. So my first statement will be my given. Line segment AB is congruent to line segment CD. Then I will have my conclusion of line segment AC is congruent to line segment BD, because if a segment is added to congruent segments, then their sums will be congruent. Looking at my last problem, problem 5, I'm given angle HEF is sup to angle EHG. Angle GFE is sup to angle FGH. Angle EHF is congruent to angle FGE. Angle GHF is congruent to angle HGE. I want to conclude that angle HEF is congruent to angle GFE. So this angle here is congruent to this angle here. Notice, remember from section 2.4, the use of double sup. If I have double sup, I'm probably going to use my supplement theorem, which was supplements of congruent angles are congruent. So I will want to show that I have two angles that are sup to congruent angles. Then I can use that theorem. So listing my four givens, I can then state that angle EHG is congruent to angle FGH, because if I have congruent angles added to congruent angles, then their sums will be congruent. Now that I've showed that EHG is congruent to FGH, I have my two angles supplement to two congruent angles. So I can state angle HEF is congruent to angle GFE, because supplements of congruent angles are congruent. In today's lesson, we learned our addition and subtraction properties. Our addition properties are if a segment or angle is added to two congruent segments or angles, the sums are congruent. If congruent segments or angles are added to congruent segments or angles, the sums are congruent. And our subtraction properties are if a segment or angle is subtracted from two congruent segments or angles, the differences are congruent. And if congruent segments or angles are subtracted from congruent segments or angles, the differences are congruent. That's a wrap on this video. We'll see you in the next one.